Look up at the night sky, a black canvas scattered with stars, each a sun, many with their own planets. These stars gather into immense galaxies, and our Milky Way is just one among billions. The universe appears ordered, planets orbit, stars shine, galaxies spin in a cosmic dance. But why doesn't it all fly apart? Why is there such harmony? This order began in chaos, the Big Bang, 13.8 billion years ago, when the universe was smaller than an atom. In a flash, it expanded, and in that instant, a perfect balance was struck. If expansion had been slower, the universe would have collapsed faster, and matter would have scattered too quickly for stars or galaxies to form. We exist because the universe got it just right. The story of the cosmos is a tale of balance, opposing forces creating a rhythm that holds everything together. Think of it as a grand orchestra. Gravity, electromagnetism, and nuclear forces each play their part. The laws of physics are the music, the same everywhere from Earth to the edge of the universe. These laws are why the universe is a cosmos, not chaos. Our quest to understand this harmony drives us to build telescopes, smash atoms, and send probes to other worlds. With every discovery, we uncover more of the intricate web of laws that hold the universe together. We are, in a sense, the universe's way of knowing itself. The more we learn, the more we see the cosmos as a place of profound and elegant balance. This journey is one of humanity's greatest adventures. It's driven by curiosity, a desire to know our place in the cosmos. The universe's harmony is not a given, it's the result of delicate cosmic tuning. Every star, every planet, every atom follows these rules. The universe is not random but a place of order. And as we look deeper, we find that balance is everywhere. The cosmos is a symphony, and we are part of its music. All you have to do is look up and wonder. Gravity, the force you feel holding you to your chair, is the great sculptor of the cosmos. After the Big Bang, the universe was a nearly uniform soup of gas and dust, but tiny clumps formed. Gravity pulled these clumps together, building the first stars and galaxies. It holds galaxies together, orchestrates their spin, and forms solar systems. Gravity shaped our sun from a cloud of gas and dust, then gathered planets, moons, and comets. It keeps Earth in orbit, giving us seasons and stability. Isaac Newton saw gravity as an invisible force pulling objects together. But Einstein reimagined it. Space and time are woven into space-time, and massive objects bend this fabric. Planets orbit the sun not because they're pulled by a rope, but because they follow the curves in space-time. Think of a marble rolling around a depression made by a bowling ball on a trampoline. Einstein's general relativity predicts the bending of starlight and the orbits of planets with stunning accuracy. Gravity is not just a force, it's the very shape of the cosmos. It sculpts everything from galaxies to the path of a falling apple. Without gravity, there would be no structure, no stars, no planets, no us. It is the silent architect of the universe. Every cosmic structure owes its existence to gravity's patient pull. The universe's grand design is written in the language of gravity. It is the force that binds the cosmos together. And its story is just beginning. If gravity shapes the large-scale universe, electromagnetism rules the small. It's incredibly powerful, but we rarely notice it because positive and negative charges usually balance out. When that balance breaks, we see its force, like in a lightning strike. Electromagnetism holds electrons in orbit around atomic nuclei, creating the building blocks of matter. It's the foundation of chemistry, bonding atoms into molecules, making water, diamonds, and DNA possible. Light itself is a ripple in the electromagnetic field. Photons are released when electrons jump between energy levels. Our eyes see only a sliver of the electromagnetic spectrum, but telescopes reveal a universe of invisible light. Electromagnetism powers our civilization. Electricity, phones, and radio waves all rely on it. From the spark in your brain to the glow of distant stars, this force connects and creates. Without it, there would be no chemistry, no light, no life. It is the force of connection and communication. Electromagnetism is the spark that brings the universe to life. Dive into the atom's heart, the nucleus packed with protons and neutrons. Like charges repel, so why doesn't the nucleus fly apart? Enter the strong nuclear force, the most powerful in nature. It acts only at tiny distances, gluing protons and neutrons together, making atoms possible. Without it, only hydrogen would exist. No stars, no planets, no life. The strong force creates the 92 natural elements that make up our world. But there's another player, the weak nuclear force. It's weaker, but it enables change, turning neutrons into protons and vice versa. The weak force powers radioactive decay and fuels the sun's nuclear fusion, releasing the energy that warms our planet. It also helps forge new elements in supernova explosions, scattering them across the galaxy. The gold in your jewelry and the calcium in your bones were born in the heart of exploding stars. The nuclear forces are the universe's engine of creation and transformation. They build the elements, power the stars, and make life possible. Without them, the universe would be simple and lifeless. They are the hidden hands shaping the cosmos from within. The story of matter is written by the nuclear forces. For decades, astronomers thought gravity and the Big Bang's momentum were locked in a cosmic tug-of-war. Would gravity win, pulling everything back, or would expansion continue forever? In the late 1990s, astronomers discovered something shocking. The universe's expansion is speeding up. A mysterious force, dark energy, is pushing galaxies apart, growing stronger over time. Dark energy acts like an anti-gravity, dominating over vast cosmic distances. Today, we know ordinary matter is just 5% of the universe. Dark matter makes up 27%, and dark energy a staggering 68%. Everything we see is only a tiny fraction of what's out there. The fate of the cosmos is shaped by these two great unknowns, dark matter and dark energy. The universe's future is in the grip of mysteries we're only beginning to understand. The universe is balanced on a knife's edge. The fundamental constants, gravity's strength, the charge of an electron, the speed of light, are exquisitely fine-tuned for life. Change any of them slightly, and the universe becomes lifeless. The strong force, for example, is perfectly tuned to allow both stable stars and a rich variety of elements. If gravity were stronger or weaker, stars and galaxies wouldn't form, or life wouldn't have time to evolve. Why is the universe so perfectly balanced? Some say it's luck. Others suggest a multiverse with countless universes and different laws. We may never know the answer, but the question fills us with wonder. The universe seems made for life, or at least for the possibility of it. This fine-tuning is one of science's deepest mysteries. We are here because the universe allows it, and that is a marvel worth contemplating. Modern physics stands on two pillars: Einstein's general relativity, which explains gravity and the cosmos, and quantum mechanics, which rules the world of atoms and particles. Both are spectacularly successful, but they don't fit together. Relativity describes a smooth space-time, quantum mechanics, a jittery world of probabilities. Where both should apply, like black holes or the Big Bang, the equations break down. This tells us our understanding is incomplete. Physicists seek a unified theory, a theory of everything to describe all forces, from the smallest particle to the entire universe. Einstein searched for it, and today new ideas like string theory offer hope. String theory imagines the universe's building blocks as tiny vibrating strings, each note a different particle or force. It's elegant but still unproven, operating at energies beyond our reach. The quest for unity continues, pushing the boundaries of knowledge. We seek a single equation to explain it all. The journey is as important as the destination. The universe's deepest secrets are still waiting to be revealed, and the search unites us in wonder. The universe's harmony is maintained by symmetries and conservation laws. A symmetry means the laws of nature stay the same, no matter where or when you are. Emmy Noether showed that every symmetry leads to a conservation law, like momentum or energy. Conservation of momentum explains why rockets move. Conservation of energy means energy can change form but never be created or destroyed. These laws govern everything from stars to your own body. They are the universe's unbreakable accounting rules. Without them, reality would be chaos. Symmetries and conservation laws are the bedrock of order. They ensure the universe is stable and predictable. They are the silent guardians of cosmic harmony. The universe is a grand symphony. Gravity shapes electromagnetism, connects nuclear forces create, and dark energy drives the expansion. All these forces work together in perfect harmony, not as separate players but as parts of a unified reality. The constants of nature are finely tuned, like instruments in an orchestra, to support life and consciousness. If anyone were out of tune, the symphony would collapse. This cosmic coherence inspires wonder and humility. We are stardust, awakened, the universe's way of listening to its own music. The symphony is all around us, waiting to be heard. The quest to understand is what makes us human. We may not have all the answers, but the search itself is beautiful. All you have to do is look up and listen.